Let's now have the empirical formula and molecular formula. Let's first define the two. What is empirical formula and what is molecular formula? Empirical formula gives us the smallest whole number ratio of the atoms present in a compound. Molecular formula, on the other hand, gives us the actual number of atoms present in a compound. So let's have a look at the examples here. So we have here one molecule which is H2O2, which is commonly known as hydrogen peroxide. So notice the molecular formula of hydrogen peroxide has 2 and 2. So the ratio of hydrogen to oxygen is 2:2. So that will be the actual number of atoms of hydrogen and oxygen present in one molecule of hydrogen peroxide. But notice 2 and 2 have 2 common factors, 1 and 2. So to get the empirical formula, you get the greatest common factor. So in the case of 2 and 2 from hydrogen and oxygen, the greatest common factor of the 2 is 2. So you divide 2 and 2 by 2 to get a smaller whole number ratio of 1:1. So the molecular formula of hydrogen peroxide is H sub 2, O sub 2, and its empirical formula is HO, or 1 and 1 atoms, or ratio. A ratio of hydrogen to oxygen is 1:1. Another example, let's have C sub 2, H sub 4. So we have here 2 and 4 numbers of atoms. So they have also have the same greatest common factor of 2. So to simplify 2:2 ratio, you can have them as 1:2 because you divide both by 2, you will get 1 and 2 as their lowest whole number ratio. So what's again the difference between molecular formula and empirical formula? Empirical formula is the simplest whole number ratio of atoms present in a compound. Molecular formula gives us the actual number of atoms present in the molecule of in one molecule or in one compound. There are other examples here, as you can see. So you have here C2H2, the acetylene. So we have 2:2, which can be simplified to 1:1. So molecular formula is H sub 2, H sub 2. Empirical formula, lowest term of 2:2, which is CH, 1:1 ratio of atoms of carbon and hydrogen. Another is benzene. Benzene is C6H6. So we have here 6 and 6. They have 1, 2, 3, 4 common factors. 1, 2, 3, and 6. So you get the greatest common factor, which is 6, and divide the subscripts or the numbers of atoms by 6. So you will get the lowest whole number ratio of 1:1. That's why the molecular formula of benzene C6 sub 8 can be simplified as its empirical formula as C sub 1 H sub 6. So that goes for most of organic compounds. Let's have here carbon dioxide at the bottom. So notice the ratio in the molecule is 1:2. There is no more factor common between the two except 1. So some compounds have the same empirical formula and molecular formula, such as carbon dioxide and many inorganic compounds. If determining the percent composition earlier has 2 steps, in calculating the empirical formula of a compound, we have 4 steps. Let me give first the steps and then apply them later in examples. Let's have step number 1. Step number 1 is to assume 100-gram starting material of the compound. If it is not given, then you convert, let's say the given amounts of the components are in moles. So you just convert the numbers of moles to gram to approximate the initial amount of 100 gram of the compound. Number 2, convert the grams of each element into moles using the element's molar mass. So as I said earlier, the molar mass of the elements are the same as their atomic atomic masses. So 1 mole of hydrogen is equal to its atomic mass of 1.01 gram. 1 mole of oxygen is equal to its atomic mass of 16 grams. So the molar masses of elements are equal to their or the same as their atomic masses as indicated or can be taken from the periodic table. Step 3. Divide the moles of atoms of each element by the moles of atoms that had the smallest value. If obtained numbers are not whole numbers, then proceed to step 4. So meaning, we can stop at step 3 if we had already gotten whole numbers. So because those whole numbers will give us the number of atoms present in the simplest formula of the compound. If not, then proceed to step 4. Step 4 states that it says that we multiply the values obtained in step 3 by the smallest number that will convert them to whole numbers. For example, you get a 0.5. So you start with 2. So 0.5 will become whole number 2. Let's say 0.33. To convert that to a whole number, you have to multiply by 3. So you choose the smallest possible number that can convert the initial numbers of atoms in step 3 as whole numbers. So let's take this example. Example number 1. The analysis of a salt shows that it contains 56.58% potassium, 8.68% carbon, and 34.73% oxygen. Calculate the empirical formula of the compound. Let's do step 1. Let's express each element percent composition in grams. So to assume 100 gram of the compound, we have learned earlier that percent composition of a compound always adds up to 100%, right? So in the case of water, for example, hydrogen is 11.21%, oxygen is 78.89%. So you add the two, you will get a total of 100%. So that is easy to process, no? So when you are given percent composition of the compound, you just change percent to gram, as easy as that. For example, in this example, the percent compositions are automatically converted to the grams of the compound. So you will have potassium, 56.58 grams, carbon, 8.68 grams, oxygen, 34.73 grams. Let's now proceed to step 2. Step 2, convert the grams in step 1 into moles. So how do you do that according to the guideline earlier? To convert gram to mole is to multiply or use the molar mass of the elements. So again, as I said, the molar mass of elements are equal to their atomic masses, which can be taken from the periodic table. Let's do this. Potassium. The given mass of potassium in the problem is 56.58 grams. Multiply that by the ratio, 1 mole of potassium equals or over the atomic mass of potassium, 39.10 gram. So you divide 56.58 gram by 39.10 gram, cancel gram, so you will have mole as the unit left. So dividing the two, you will get the answer 1.45 moles. So that will be for potassium. The same process you will do for the rest of the elements in the compound. So the second element in our problem is carbon. The given mass of carbon is 6.68 gram. You multiply that by the ratio or conversion factor 1 mole of carbon over the atomic mass of carbon, 12.01 gram. You cancel gram, numerator, denominator, and divide the two. So you will have 8.68 divided by 12.01, and the answer is 0.72 moles. And for the third element, oxygen, the given mass is 34.73 grams. Multiply that by the conversion factor or ratio, 1 mole over the atomic mass of oxygen, 16.00 gram. Cancel again gram. divide the 2, you will get 2.17 moles of oxygen. So now that you have computed or calculated the moles of the atoms in the compound, let's go to step 3. In step 3, you will divide each number of moles by the smallest mole or the smallest value, no? So among the three, which gives us the smallest number of moles? It's 0.72 moles. So you will divide each number of moles of each element in the compound by that smallest mole of calculated mole. So in the case of potassium, the calculated mole of potassium in step 2 is 1.45 mole. You divide that by the smallest mole, 0.72 mole. You cancel mole, you will get the answer 2.0. There will be no more unit because you have canceled the mole and mole. So in this step, you already have a whole number because that gives us the number of atoms present in the empirical formula of the compound. Let's have carbon. The calculated mole of carbon is 0.72 mole. It happens that this number of mole is the smallest number of moles. So 0.72 mole divided by itself, the same number of moles, 0.72 will give us 1 or 1.0. You again cancel the mole. No, not yet. Another is for oxygen. The calculated moles of oxygen is 2.17 mole. Divided by the same number, smallest number of moles, 0.72, you will get the answer 3.0 or simply 3. So the ratio of the atoms of elements potassium, carbon, and oxygen is 2:1:3. So the empirical formula is K subscript 2, C subscript 1 or none, no need to indicate, and O subscript 3. So that's how you calculate or determine the empirical formula given the percent composition of the compound. Let's have another example. Let's have this. The percent composition of a compound is 25.94% nitrogen and 74.06% oxygen. Calculate the empirical formula of the compound. So again, doing the procedures or the steps. Step 1, express the percentages of the elements in grams. So assuming 100 grams, you just convert percent to grams. So you will have nitrogen 25.94 gram and nitrogen 74.06 grams. Step 2, convert the grams to moles. So doing the same process as in the first example, divide the given mass by the atomic mass. We have, or the molar mass of the element. So for nitrogen, the given mass is 25.94 divided by the atomic mass or molar mass of nitrogen from the periodic table, it's 14.01 gram. You cancel gram, so you will get the unit mole, and the answer for that is 1.85 mole. So dividing the two, you will get 1.85 mole. For oxygen, the given mass is 74.06 grams. You divide that by the molar mass of oxygen, which is again, rather oxygen from the periodic table, you will get 16.00 grams. So dividing those, you will get the number of moles, 4.63 mole for oxygen. Now that you have converted gram to mole, you choose between the two numbers of moles, the smaller. The smaller is 1.85 mole. So to do step 3, you divide both numbers of mole by the smallest number of mole, which is 1.85. So for nitrogen, we have 1.85 mole divided by itself, we will have 1.0. For oxygen, 4.63 mole divided by 1.85 mole, cancel mole. So the whole number or the answer will be 2.5. Notice that you did not get whole numbers. You have 0.5 as decimal. So in that case, you proceed to step 4. In step 4, you choose a small number, which when you multiply by the initial numbers of atoms, you will get you will convert them to whole numbers. So in this case, let's choose, if they're not possible with 1, let's choose 2. So multiplying both by 2, you will get 1 times 2. For nitrogen, you will have 2. Oxygen, you have 2.5 times the same number 2, you will get 5. You will now have the empirical formula as N sub 2 O sub 5. So that's how you can get the empirical formula. I hope that's clear. Let's now move on to the last topic, molecular formula. Molecular formula is related to empirical formula. Molecular formula can be calculated from the empirical formula given the molar mass of the compound. This time, we will need to determine the value of N. What is N? N is the number of units of the empirical formula present or contained in the molecular formula. To determine the value of N, we divide the given molar mass of the compound divided by the mass corresponding the empirical formula. So before you can get the molecular formula, you have to first get the empirical formula of the compound. If it's not given, sometimes in problems, the empirical formula is already given. You will just do the process of determining the value of N, that's molar mass divided by the molar mass of the empirical formula, and then you will use that value of N to determine the molecular formula. Let's try this example. What is the molecular formula of a compound which has an empirical formula of CH sub 2 and a molar mass of 126.2 grams? This is what I am saying. If you are already given the empirical formula, you just get the molar mass of that empirical formula and then use that as the divisor for the given molar mass to get the value of N. And then the rest follows. Let's do step 1. In step 1, you calculate the mass of each unit of CH2. So in the empirical formula, we have 2 kinds of atoms, carbon and hydrogen. How many carbon and how many hydrogen atoms? So we have 1 carbon and 2 hydrogen atoms. So to get the molar mass, this is the same as what we did in determining or computing for the percent composition. Before we were able to calculate the percent composition, we first computed for the molar mass. So this is the same thing. So how many atoms atom of carbon times the atomic mass of that carbon? Hydrogen, how many hydrogen atoms times the atomic mass of that atom? So we have 1 carbon times the atomic mass from the periodic table, 12.01 gram will give you 12.01 gram. For hydrogen, we have 2 atoms times 1.01 gram equals 2.02 grams. So you get the total, you will get a total of 14.03 grams. So to get the value of M, step 2, divide the given molar mass by the calculated molar mass of empirical formula. The given molar mass is 126.2 grams. You divide that by the calculated molar mass in step 1, which is 14.03 grams. You will get the whole number. You divide and then cancel gram. You get the number 9. So that value of 9 is the multiple of your empirical formula. Gives you the multiple of empirical formula. So what will be the molecular formula for our compound? So from the empirical formula is CH sub 2, close parenthesis, subscript 9, the value of N. And then distribute 9 to the subscripts. So the molecular formula for the compound will be C sub 9, H sub 18. So that is a simple example for getting the molecular formula of a compound. This next example will be for your practice. So let me read. A sample of a compound containing boron and hydrogen contains 6.4 gram of boron and 1.80 gram of hydrogen. The molar mass of the compound is about 30 grams. What is the empirical formula? So you can go over your notes. You can check books, search the net. You try to answer this by yourself. And then for the summation of the lesson, let's answer the following questions for the generalization. Question number 1, what are some of the isotopes and their uses? 2, how do we represent compounds using chemical formulas? 3, how do we name compounds given their chemical formula? 4, what are the steps in calculating the empirical formula and molecular formula? So your answers will wrap up this lesson. I hope you got all the salient points from all the videos I presented for this particular lesson in your General Chemistry 1. So I hope to see you again next time. Watch out for the next videos for the next lesson in General Chemistry. So that will be all. Thank you for watching and listening. Until next time.